relationship or it is participation, that is called supervisor. Wherever two is there, that is called subordinate or the worker, we can say. Like this, we can establish a relationship type that is called recursive relationship type. Whatever relationship is performing or participation is performing here only between employee to employee only. Okay. From one end, a supervisor, employee as a supervisor, and another end, employee as a supervisor. Okay, supervisor or supervisor. Okay. So like this, we can show how the recursive relations can be established. Okay. So here we have the example: employee is there, employee as supervisor, and employee as supervisee. Okay, both are supervision. One employee supervision on n number of supervisee or n number of supervisee from one supervisor. Okay, this is called recursive relationship type. Recursive relationship and recursive relationship type. Okay. I think almost every concept discussed how to write a ER diagram and what is total participation and total minimum participation. We'll see here. Okay. So attributes of relationship types. So not only for entity type, even we can give the attributes for relationship type. You people know, right? What do you mean by relationship type now? What is relationship type? It is a name given to or established between two entities. Relationship type is a name given to established between two entity types. Okay. Now, so a relationship type can have attributes. Even the relationship type can have attributes like works for. Works for means or works on. Works on means how many hours employee works on some projects. How many hours employee works on some projects or how many hours employee or manager works for a department. Okay, that is one relationship type we can see. Okay, for example, hours per week of works on, it's a value for each relationship type instance. It's a value for each relationship type instance. Okay, which describes the number of hours per week that an employee works on a project. A value of hours per week depends on particular employee or project combination. Okay. Most relationship type attributes, most relationship type attributes are used with M is to N, means many to many relationships. In 1 is to N relationships, they can be transferred to the entity type on N side of the relationship type. See, in this example, we have a relationship type instances or attributes. See, I can write it and I'll show you how to write a relationship type attributes. Okay. Let us take, I have here entity is there, that is called employee entity. Okay. And I have a project. Same example we'll take. Initially, project. And now I have a relationship type works on. Okay. This is the works on relationship type. Okay, maybe n number of employees, m number of projects or participation, like total participation. So that's why single line. If it is partial participation, then that is double line. Okay. Now for works, we can say we can write the number of hours. Number of hours or hours per week, hours per week. Okay. So like this, I can give the attributes for relationship type itself. The attributes for relationship type itself. Managers. Okay. Managers is another relationship type between employee and department. Okay. Employee and department. Okay. Again, here also number of employees and one department can have participation, total participation. Okay. And managers, see here we have a managers when is started to manage the department. Okay, managers, we have one attribute called start date. Start date and end date, we can write start date and end date, because when the department has started to control by this employee and when he is ended that department handling the department. Okay, maybe that each behavior or each attribute we can take as a relationship type attributes. See, works on and works for, we don't have. Works on is have hours, and your manages start date. Okay, like this we can give the relationship type attributes of relationship types. Clear? Yes or no? Okay, notation for constraints on relationships. Notation for constraints on relationship. Already have written. Just I'll brief once again. Cardinality ratio is nothing but a binary relationship that is between two entities. The relation between two entities is nothing but relationship type or binary relation. It might be 1:1, 1:n, n:1, or m:1. Okay, this is called notations. Shown by placing appropriate numbers on the relationship edges. Okay, as I shown here, this is called relationship or notation of cardinality ratio. Notation for cardinality ratio, like n:1, 1:1, m:n. Okay, these are called notations for cardinality ratio. Okay, participation constraint on each participating entity type is to total or partial. Okay, like see, total participation constraint means on each participating entity type, like from one there is a employee and department. No, employee one participation, department is another participation. Sometimes it is might be a full participation, partial participation, or maximum participation. Okay, that is called total versus partial, or partial versus total. So that is called total shown by double line and partial by single line. Okay, total is double line and partial is single line. That is the notation of participation ratio. Okay, and there is another notations like alternative notations for cardinality ratio. Min or max, min comma max notation for relationship structural constraints. This is for structural constraints. See here, as I said, minimum is 0, max is 1, and max to max is 1 to 1. Okay, this is what we can give as a participation ratio. Okay, so instead of this, I can give 0 comma max and max comma again max comma 0. Okay, like this I can give participation ratio like 0 comma 1, 0 comma n, and 1 comma 0, that is minimum to maximum. Same thing here given is specified on each participation of an entity type E in a relationship type R is a entity and R is a relationship type. Specifies that each entity in E, capital E, participates in at least a minimum and at most maximum relationship instances in R. Okay, if any take default is no, if there is no constraint, minimum is 0, maximum is n. Significantly we can, there is no limit. Okay, and we must have min is less than or equal to max. Okay, this is the case where minimum is greater than 0 and maximum is greater than or equal to 1. Okay, so this is what the structural constraint must be given, derived from knowledge of mini world constraints. Best example is a department has exactly one manager and an employee can manage at most one department. Okay, any department exactly having one manager and an employee can manage at most one department. Okay, which is specified in like specify 0 comma 1 for participation of employee in managers. Okay, at most one manager for one department. Specify 1 comma 1 participation of a department in managers. Okay, there are n departments, n managers must be managed. An employee can work for exactly one department, but a department can have any number of employees. An employee can work for exactly one department, but a department can have any number of employees. Okay, that is what the participation ratio is mentioning in structure constraints. Okay, specify 1 comma 1 participation of employee in works for and 0 comma n for participation of department in works for. Okay, so different ways we can, so based on the situation we can represent, right? See here, this is called structural constraint. The notation for relationship constraint employee department. Okay, might be there are 0 employees, at least one department, at least one employee, one department, a maximum employees, at least one department. Okay, like this we can give. See here, 1 is to 1, 1 is to n, 1 is to 1, again 1 is to n. So read the min max numbers next to the entity type, looking away from the entity type. So this is what we can say. Instead of giving single participation, you can give double participation, like constraints, like structure constraints. Okay, these are the popular notations to use to write the ER diagram. Okay, see, symbol rectangle representing entity. If it is a double rectangle, weak entity. Rhombus, relationship. Double rhombus, identifying, okay, identifying or identifying relationship. Okay. or a weak relationship type. And oval shape with the arrow attached, that is called attribute. Oval shape with underline, that is called key attribute. Double oval shape, that is called multi-valued attribute. Okay, this is called composite attribute. Okay, one oval, again it is subdivided into many sub-oval shapes, that is called composite. And derived attribute is represented in, which is the derived attributes stored versus derived. Age is derived from date of birth. Okay, that is called, that is represented in dotted line. Okay, total participation E2 in R. Okay, E2 in R, total participation. This is called cardinality ratio 1 is to N. E1 is to E2 in R. Okay, E2 and E2 and structural constraints. Okay, we can represent min max. Okay, min max on participation of E in R. Okay, go through once. This completes the third chapter also. In fourth chapter, little bit is there in the first module. We'll see in the next class. Okay. Okay, now if you have any doubts, you can ask me.